Yes. Cek, cek, cek. Cek 1 2 3. Cek 1 2 3. Tes, tes. Kedengeran, Mas? Cek, cek, cek.
Suara saya kedengar nggak, Mas?
Cek 1 2 3.
Bagus, Am.
Siap, siap. Enggak, Bu, dari ruangan, Bu. Ngecek yang dari...
Oh, oke. Aku terima kasih udah di-admit ya.
Siap, Ibu.
Halo, tes, tes. Jelas nggak? Cek, cek, cek.
Masuk, masuk. Clear.
Oke, tes, masuk ya?
Masuk.
Oke, terima kasih.
Sorry.
Tes. Agak keras ya. Atau iya.
Perlu dipijit ya. Halo. One two. Tes.
Tes suara masuk.
Masuk, Mas.
Oke, Pak Am, ini mau sudah pukul 1, mau di ini?
Ya, monggo ready.
Sebentar kami cek dulu.
Tes.
Tes.
Oke, jelas. Coba ulang lagi, Mbak Diva.
Tes.
Oke, jelas di saya.
1, 2, 3.
Oke, siap.
Yep, 1, 2. Okay.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Ladies and gentlemen, welcome to today's international webinar with our theme, Support for the Nation's Capital Nusantara or IKN, Soft Soil Treatment and Immersed Tunnel. In this beautiful moment, I would like to welcome the Honorable Mr. Atyanto Busono, the Chairman of the Organizing Committee, the Honorable Mr. Danis Sumadilaga, the Chief Executive of the IKN Task Force of the Ministry of the Public Works and Housing, the Honorable Mr. Sung Hwan Kim, the President of the Road Engineering Association of Asia and Australasia, or REAAA, the Honorable Mr. Il Ku Kang from Jun Construction, the Honorable Mr. Sang Kyun Jeong from Daewoo ENC, and the Honorable Mr. Sugiartanto, the General Chairman of the Indonesian Road Development Association, or Hpji. Once again, we thank you for the presence of our speakers and respective guests. And we also welcome all the participants of the webinar today who also join us online. And on this special afternoon, we have several agendas. So allow me to read several sequences of our agenda. The first is the opening, which we previously had read together. The second will be singing Indonesia national anthem. The third is a welcoming speech. The fourth is opening remarks. The fifth is our core event webinar, the discussion on our topic, soft soil treatment and immersed tunnel. And the last one is closing. And step on to the following agenda is the singing of Indonesia Raya, who will be led by Mr. Amrullah. Kindly please, all the respective guests, please to stand up for singing Indonesia Raya. Thank you very much. All guests, please have a seat. Ladies and gentlemen, the next is opening speech that will be delivered by the chairman of the organizing committee. Please welcome Mr. Atyanto Busono.
Ya, bisa. Terima kasih. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera buat kita semua. Om Swastiastu. Shalom. Salam kebajikan. Yang saya hormati Bapak Kasatgas Pelaksanaan Pembangunan Ibu Kota Negara Nusantara, Bapak Dr. Insinyur Danis Sumadilaga, MSc. Yang saya hormati Bapak Ketua DPP Hpji, Bapak Sugiartanto. Yang saya hormati Bapak-Bapak Ketua DPD dan juga Sekretaris Hpji seluruh Indonesia, para narasumber, Bapak Dr. Sumbuang Kim, Bapak Ilko Kang, Dr. Sang Kyun Jeong, Dr. Sang Kyun Jeong dari Daewoo dan juga Jun Constructions. Thank you for your coming. An opportunity to give presentation in this webinar, and hopefully your experience and knowledge, particularly in soil and Immerse Tunnel implementations, will share to Hpji member, this Indonesian Road Development Association and this webinar participant. Seluruh juga yang saya hormati Bapak Ibu peserta webinar Hpji, ada dari para akademisi, dari teman-teman Satgas, para badan usaha di bidang jalan dan jembatan. Pertama-tama kami ucapkan bersyukur kepada Tuhan Yang Maha Esa atas perkenannya kita semua dapat mengikuti acara webinar kali ini dengan kondisi sehat. Webinar kali ini merupakan rangkaian series webinar tentang IKN, khususnya kali ini adalah spesial ya, prakarsa dari Bapak Kasatgas, Pak Danis yang memberikan kesempatan bagi para penyaji, Bapak Dr. Sumbuang Kim dan tim yang juga Presiden REA ya, yang saat ini sedang berkunjung ke Indonesia, dan kami laporkan kepada Bapak Kasatgas, peserta pendaftaran mencapai 500 dan kali ini sudah 259 peserta. Alhamdulillah, mudah-mudahan bisa masih tambah lagi dengan topik soft soil treatment dan Immerse Tunnel dalam rangka mendukung pembangunan IKN Nusantara kita. Demikian, mungkin saya nggak berpanjang lebar. Saya ucapkan kesempatan ini terima kasih kepada panitia, terutama yang mengurus sampai terselenggaranya acara ini dari DPP Hpji, kemudian teman-teman Satgas, yang telah membantu sampai terselenggaranya webinar ini. Mohon maaf bila nanti ada kekurangan dan dalam penyelenggaraan kali ini. Selamat mengikuti webinar. Wabillahi taufik wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much to Mr. Atianto Busono for the opening speech. Next, we have opening remarks by the Chief Executive of the IKN Task Force of the Ministry of Public Works and Housing. Please welcome Mr. Danis Sumadilaga.
Okay, thank you. Bismillahirrahmanirrahim. Yang saya hormati Ketua Hpji, teman-teman Satgas IKN, hadirin, and then presenter, ya, kemudian audience from online and offline audience. Assalamualaikum warahmatullahi wabarakatuh. Salam, Om Swastiastu, Namo Buddhaya, and good afternoon. Welcome to our international webinar. Yeah, as you may already know that now Indonesia is preparing to move its capital city to East Kalimantan. We are now preparing to build infrastructure. Yeah, there are two things very specific relate to this international seminar. We know that the soil condition in East Kalimantan, especially in the location of new capital city, is very specific. So maybe we need a certain treatment to improve it. And also as a part of toll road development, we are going to build an Immerse Tunnel, which is maybe a first experience for Indonesia. That's why today, we invite some expert, as already mentioned by Pak Atianto, who has a lot of experience in soil treatment, and also from the Daewoo, if I'm not mistaken, who has experience to build Immerse Tunnel in many places, like in Korea itself, in Iraq, yeah, and some other places. So in order to achieve the good infrastructure and also to have an insight for us, it is important for us to have a sharing knowledge from the expert today. So without further ado, I declare let's start the international webinar. Mr. Kim and my friend, please share your experience. I hope that we in Indonesia, many stakeholders attend this, will have some experience, will give us a new insight, as I said, yeah, regarding the soft soil treatment and also Immerse Tunnel, and will trigger us to continue expanding on expertise and professional skill to build our new capital city. Thank you.
Thank you. Please give a round of applause. Thank you, Mr. Danis, for the opening remarks. Next, before we go to our core event, the Ministry of Public Works and Housing would like to give the certificate of merits to our respectable speakers here that will be handed by Mr. Danis. We welcome the first speaker, Mr. Dr. Sung Hwan Kim, the President of REA. The second speaker, Mr. Il Kukang from June Construction, and the third speaker, Dr. Sang Kyun Jeong from Daewoo ENC. Please, the floor is yours.
Okay, picture.
Okay, thank you. Okay. Thank you very much, Dr. Sun Hwang Kim. Kamsahamnida, Mr. Il Kukang, and Dr. Sang Kyun Jeong. Our next agenda is our core event of our webinar today, the panel discussion of soft soil treatment and Immerse Tunnel. And in this session, will be guided by a moderator. And our moderator today here is Mr. Dedi Gunawan from the Directorate General of Highways. Welcome, Mr. Moderator. And the floor is yours. Thank you very much.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang. Good afternoon. Annyeonghaseyo. First of all, thank you for the opportunity given to me as a moderator. I think it's a very great opportunity to me. And thanks to Pak Adianto and also Pak Danis as initiator in order to conduct this international webinar. I think the number of participants is increased already. almost 500, I think, and then it's very great. Okay, all right, ladies and gentlemen, and also the participant. As mentioned before by Pak Atianto and also Pak Danis, that today we will talking about the soft soil treatment and also immersed tunnels. We will hear about the experience of the Korean experts. So there will be a 4 speaker here. First is Dr. Sun Han Kim, the president of Road Engineering Association of Asia and Australasia. In fact, he is a civil engineer who graduated from Seoul National University and also doctoral degree from the Ohio State University. I think he has many experience in the civil engineering project, and he has many medals he's already got from the Republic of the Korea, also from the USA. So it's very good to us to hear about his experience related to the soil treatment. And then the second speaker will be Mr. Il Kukang from the June Construction. He is also expert in the soil treatment methods. In fact, he is a chief officer of June Construction, graduated from Yonsei University of Civil Engineering. He is involved in many projects. I wonder also is involved in the Sumatra Highway project. So I think he has experience in Indonesia and also in the reclamation of the marine works in Western Coast, Tuas Western Coast. And then the second speaker is, the third speaker is Dr. Sang Kyun Jeong. He will present 2 projects about the immersed tunnels, the basic of introduction of the immersed tunnel and also the application of the immersed tunnels in Korea and as well as in the Iraq. He is a senior structural engineering or general manager of Daewoo Engineering Consulting. Now we also have experience in design for the Kutikul terminal Hpji in Indonesia. So also I think he has experience in Indonesian situation regarding the related to the soil and also related to the tunnel project. So without further ado, I think I will invite Mr. Donsung, Mr. Kim to present the first material about the problematic issue in the soft soil treatment. Please, Mr. Kim, the time is yours. Sorry that the allocation time is 30 minutes.
Okay. Oh yeah, it's my turn. Thank you, Moderator
Please.
Pak Teddy and Pak Hadianto and organizer for this seminar. Yeah, it is my great honor to have this kind of big webinar in Indonesia. Actually, we have passed through the long tunnel with, I mean, COVID-19, but now we are getting better and better. So anyway, I have but this kind of some seminars inviting our some engineers. And so anyway, as you know, I mean, human beings can learn from a history. So I'm going to share my history through this presentation. Here, the history means not my life history, but I'm going to share with a kind of accumulated experience last 40 years. So actually, but I have only 30 minutes to share, but not enough time to discuss in the full contents. But the following speaker will describe in some detail about soil treatment method. So I have to run, I mean, to present. Actually, the first slide shows a group of field engineers. Actually, I visited your construction site nearby Pasuruan road project. They are Waskita area field engineers. Actually, I got I had a kind of a simple, not simple, actually consulting by myself, because Batanis invite me and help, I mean, to their, I mean, field engineers. So I got a chance to visit there. Actually, they are very active to work. They are very proud to complete their project, as I remember. Okay. Okay, but I have this some contents, but I will follow through that contents. Actually, this is a kind of a theme, I mean, for today. If you fasten the first button very well when you wear your suit, then you will step on the right foot. So probably this is a kind of first step to what the where to, I mean, start, I mean, your IKN big project. So maybe the my objective will be to minimize trials and errors in advance. So before I get into the main subject, I'm going to show some disasters which you can get from our construction or operating site. They are showing a kind of landslide during the heavy rainy season, another landslide, and big slide. We got this big slide in Korea during the rainy season. Actually, this is another slope. I mean, the bridge failures. Actually, they placed a very poor foundation for the pier, bridge pier. And this is some toppling collapse during the earthquake. Probably I got this one from Japan. Actually, we have very sad story about this, what the bridge falling. Actually, the main problem came from some poor maintenance. Actually, the center span has been fallen down, and maybe around 30 high school students passed away during this collapse, maybe around 30 years, maybe around 25 years ago. And this is another disaster which got the fire in I mean the tunnels. We have getting number of tunnels in Korea. I think you may need more tunnels in Indonesia as well. And this is another big car crash during operation, and another, it looks like a junkyard, right? Actually, we have very heavy, I mean, fog early in the morning during autumn season. So they cannot see anything in early this morning. So maybe 100 vehicles involved in this, I mean, the crash. And another big traffic jam like this, maybe Lebaran holiday in Indonesia and Chuseok holiday in Korea. So this is some very poor and very bad, I mean, damage cases on concrete pavement. I think you may have very similar, not many, but you still expect some this kind of damage on concrete pavement. This is some other examples for asphalt pavement, and a kind of sinkhole, and another scoring issues on asphalt pavement. So the reason why I'm showing this kind of disasters, but actually some of them cannot be controlled by human beings, but most of them can be managed by human beings, especially civil engineers. That's our duty. So probably the soft soil foundation is another big issues we have to discuss. That's why I'm showing some disasters before. As you know, we have many this kind of engineering infrastructures from the rock slope side, even dams to reserve the waters, and big buildings and harbors, and so on. So as the areas of social and economic activities getting expanded, and then you may need more area to install infrastructures along the coastal area. So that means you need, some area which has soft soil ground, so you have to pay more attention. Even IKN may have to install your infrastructures on soft soil ground. So that's why we have some seminar here. Now I'm going to get into the main subject about the soft soil ground. I think this is very simple. This is a kind of basic knowledge for civil engineers, but let me say briefly about the basic concept. Actually, soft soil ground has these four major the characteristics: low bearing capacity, high settlement, low permeability, and liquefactions. But the definition for soft soil ground is a little different, depends on the country specification. But normally we say if the clay organic soil has M value less than 4, then we can define the ground as soft soil. Actually, we need a very specific treatment. So based on this concept, maybe I can go further. So engineering what the properties on soft soil has 3, items, which will be summarized again. Actually, major the properties will be slope instability, varying capacity failure, excess settlement before and after construction phases. Actually, those the failures caused due to shear strength and high compatibility. So if I summarize this, properties, engineering issues, maybe I can summarize 2, the terminology: stability and deformation. Maybe we may have to focus on these 2 the terminology. Actually, stability will be used in even structural engineers, some other engineers, but for soil engineer may related to shear strength. So actually, there are 3 materials for civil engineering structures. For steel material may relate to tensile strength, concrete may be compressive strength, but soil will relate to shear strength. So now I'm going to talk about shear strength for soil materials. So for embankment, so we will discuss shear strength instead of any tensile, any compressive strength. So see, this is some basic concept of shear strength failure. Because I'm just focused on soil embankment, not any the infrastructure. So actually, road embankment combined one soil material, but they have 2 different stiffness conditions. For the foundation, they have with soft soil, which has a very high very small amount of strain, large strain, but very strong stiffness. But embankment soil has a very low strain and very low strain with high stiffness, right? So those two, I mean, material condition combine into the embankment. And once we start the space construction, I mean, earthwork, then there will behavior and different, I mean, actions. So that's why we have a kind of shear, I mean, slope failures. This is showing some examples which you got the shear failure on construction site. This is another example. It's very common at the very beginning, but now maybe if once you have very some advanced knowledge and experience, you can reduce the number of this kind of shear failure. Actually, this one shows some example during operation. Maybe if you have a shear failure during construction stage, maybe you can repair. But if you have this one during operation, it's not easy to repair. So you have to spend much time and budget. So the second important property will be deformation. So which is related to settlement for soil material. I think this is a very basic concept as a soil engineer. Immediate primary consolidation and secondary consolidation. Probably you may focus on primary consolidation settlement, which you will apply some treatment method. So maybe Dr. Gang will explain more about how we manage primary consolidation settlement. But if you cannot approach this primary consolidation settlement very well during construction, maybe those problems will shift to secondary consolidation. So you will get many problems during traffic operation. So you have to pay more budget than time as well. So this one shows some examples how we got the secondary settlement. So much undulation here, right? Probably Hadianto, you are good golf player, right? Yeah. So if you go out to play golf on this kind of fairway with the undulation, but not easy to hit the ball, right? So even the drivers, I mean, if you have this kind of undulation, they will get upset. But anyway, civil engineers should solve this one for your user, I mean, and some other additional example. And here's another very good example for the failures in bridge abutment. Actually, if you install the bridge across the soft soil layer, probably if you install the pile foundation, maybe you may ignore the soft soil layer at that area because you adopted a pile foundation. So you may say, okay, we don't need to take any treatment for soft soil, but you will get in trouble otherwise. So see, this is a good example which I got from Korea Highway Corporation. And actually this bridge, I mean, pile get cracked and tilted, I mean, overturning during operation. So this is was some schematic diagram how they got the impaction from the soft soil layer. So lateral flowing, right? So impact to the file. And so at the very beginning in Korea, we had many problems like this kind of bridge, I mean, fears. Probably you may have, if you don't you don't study about this soft soil characteristics. Actually, I got this photo from one, paper from your country. I don't know, Dr. From Catholic University, somewhere. Actually, he prepared this report, and actually the abutment totally, overturned by soft soil layer. So you have also experience about this one, and this is some other example. Actually, if you widening of your existing road, actually you may expect a differential settlement between old and new embankment, right? So maybe not around because you are busy to build a new road around, but later, if you want to expand existing road, you may expect this kind of issues. Actually, this is another good example for building engineers. Actually, I got this example from Malaysia. Actually, they built this campus building, actually complete 2003. Once they opened this building to student, right after there, and student found the cracks on the classrooms. Many, I mean, what the supervisors visit there and to find out the reason. Actually, this building was built on 5 foundation, as I mentioned in abutment. Actually, they apply the 5 foundation. That means they don't care any soft soil issues under this building. Even they had around 17 meter of soft soil layer. According to their design data, actually each concrete file allowed around 400 kilonewton as a allowable bearing capacity. But when they measure the what the pile, I mean, loading, and they got over 600. That means what each pile overloaded about 200, right? They didn't find any the issues. Why I mean each pile had that much, I mean 600 kilonewton. So the reason why, can you guess? That's negative skin friction from soft soil. This is very important. They didn't realize the issues. So this is what the negative skin friction, right? They will act like overloading, I mean, pressure on the fire. Now, let me briefly, discuss about the distribution of soft soil in Indonesia, but I don't have much information about it, just, the map, and actually your country surrounded by the ocean. That means you have lots of soft soil area, right? The bottom shows the map of Kalimantan. Actually, southeast has much, the pit layer. So you may have to more focused on how to treat this pit soil. I think you know about the characteristics and properties of pit soil. As you know, but organic content usually over 75%, and high water content. And actually, pit soil has very firm engineering properties, as you know. But fortunately, the depth of a pit has a very thin depths. So normally 50 centimeter to 300 centimeter, very thin layers. So that means a little easy to treat. But anyway, under the pit, you may expect another soft layers, shale and some others. So you have to focus on this material layer again. Engineering property, I don't skip. Let me give you an example about the Korean Peninsula. This is a map of a Korean Peninsula. Actually South Korea, actually my country, surrounded by ocean. That means my peninsula formed with the soft soil ground like your countries. And actually we had experience about the soft soil treatment since 1971, many years ago. And we once started to build the main route along the south coastal area. And then we built another expressway along west coastal line. So this is some expanded route. So that means my Korean engineers had much, I mean, experience about how managed, I mean, soft soil treatment. Okay, now summarize some working process. Yeah, maybe good enough for me. So actually, I classified the 4 cases. Maybe you know about this one. The first will be geotechnical investigation, design, construction, and maintenance. Actually, geotechnical investigation seems simple, seems not important, but very important for the soft soil construction site. So during this investigation, you may check many items, but the most important items from this geotechnical engineer will be soil properties and soil stratigraphy. So, you know, I mean, all these items is very basic. So, but here I want to suggest one thing, how we integrated the beginning, very first information. So many years ago, we used database. That's 2D systems, right? But in current BIM, building information modeling, right? That's a global kind of a trend. If once you integrate the whole beginning data from geotechnical investigation, then you can use this data into the design, construction, even for maintenance. Very important. For your new capital city, you should have this one for maintenance. Even so in Korea, we don't have any this very basic, we have basic database, but we don't have BIM now, BIM information. So now we start to build, I mean, transfer from database to BIM. But now in Indonesia, maybe you can start here. It save a lot of time, budget later. Design phase, actually, 4 factors are very important. First, type of soft soil layer from geotechnical investigation from like this. So you have to figure out the profile. And second, with size of upper structure. If you have a small size of upper structure, you don't need to worry about any soft soil. But if you have a bigger structure, you have to consider, I mean, soft soil, right? So the other will be construction cost and time period. So if you allow the longer construction time, then you can take cheap, I mean, treatment method like a PVD. But in your case, you don't have time. You have to hurry. Or to hurry, then you have to pay more cost, I mean, more money. I don't know, you have that much money, but you have to ask your president to extend. So maybe Dr. Gang will explain how we adopt the best, I mean, method for your site. There are many methods in the textbook. So maybe Dr. Gang will describe the advantage and disadvantage of each treatment method. Now talk about a little bit the construction phase, and during construction phase, and you may expect your strengths of failure. But here, actually field engineer need lots of knowledge about geotechnical engineering, because a civil engineer should take care of very wide range of field. I mean, knowledge, even bridges, even tunnels, even many things, materials, right? But they don't have much, I mean, deep step knowledge in geotechnical engineering. So maybe I can suggest later. So actually, you can get some support using the monitoring system during the construction. This is my suggestion. According to our experience, probably your construction site has only these organizations, directors and some field engineers. But these field engineers knows many things, but very wide, but they don't know a deep knowledge about soil. So in our case, we second our special geotechnical engineers to this site. It was very helpful. You don't need to pay much, I mean, budget, very short period, only for this treatment period. And also you have to train your engineer, field engineer. You don't need much budget, easy, but you have to take care of this one. Then, so and field engineer can supervise as much as they know. If you take a trip to any, for example, Korea, maybe if you once know, I mean, some Korean historians or other, before you take a trip, then once you visit there, you know many things. You can see many things, right? So that's the same way in construction. So let me get the closing remarks. Actually, I got this one from your professor. I mean, this Parahyangan Catholic University. He published a paper. Yeah. So he said most failures of subsoil ground cause from negligence. So difficulty in subsoil ground. Maybe field engineer got some pride. Okay, it's easy, a piece of a cake, but you get some problem, get in trouble. So lack of knowledge for subsoil engineer, lack of a database. And then, as I mentioned, we have the second, I mean, dispatch geotechnical engineer to construction site, just short period of time, and provide training and build a database using GIS and BIM. Then you can save a lot of budget and construction time, I think. And Dr. Kang will discuss soil settlement, subsoil treatment method in detail. Okay, can you see this screen? Maybe you know, have you seen this one? That screen?
Yeah, very famous one.
Oh, very famous in the world, right? Yeah. The Squid Game in Korea, even, yeah, I watched it here. Actually, if your construction site get kind of a guider, I mean, to take the tour. And if you educate your field engineers, then you can succeed. You can play this kind of a Squid Game in your construction site. Otherwise, you will get very dangerous, right? So dispatch some specialist, very short period, educate your field engineer, then you can finish your project within your construction period, I think. Okay, this is my end of presentation. Oh, very short, very basic concept, but just remind my experience. Thank you very much. Thank you.
Thank you, Mr. Kim. Please applause. I think it's very great knowledge already shared to us that the important thing is database. I think we have to develop the database, especially for the soil, because most of the soil properties in Indonesia is contained of subsoil. And then I think our Director General already issued the Director General decree that all the design should use the BIM, and we are already used in some project, I think. Thank you for Mr. Kim, and then Mr. Kim already shared us with related to the basic concept of the subsoil treatment, that we have to care about the stability, settlement, and bearing capacity. And then I think in the settlement and stability, we have many methods to take care about this matter. And then I think Mr. Il Kukang will present about the soft soil treatment. So please, the floor is yours, Mr. Kang.
Yes, good afternoon, ladies and gentlemen. My name is Kang from June Construction, Korea. Thank you so much giving us a chance to present Chairman and Director. I'm going to present you our company and our works and several soft ground improvement method and our proposal for the Ibu Kota Nusantara. At the beginning of my present, I'd like to introduce our persons. Mr. Han. 이쪽으로 이렇게. Is the CEO of June Construction. He's a kind of adventurous man. He established the June Construction 24 years ago during our IMF period. He likes to walk in abroad. Where the project is, he flies anywhere. Dr. Lee is a doctor of soil mechanics. He has reviewed our contract design documents. When you find the discrepancy between the job site and the design, he submits the report to the client for their consideration. For this presentation, he simulated the computer program to get optimum proposal under the assumed soft parameter and conditions. And I'm a chief technical officer of June Construction. After my 20 years construction company experiences, I've joined to June Construction for 24 years. From Jakarta to Incheon Airport, Korea, takes 7 hours flight. And from Incheon Airport through the West Coast Expressway up to our head office needs another 4 hours drive, maybe 11 hours take. As you see, our building is small, but I'd like to say our achievement is big. As an example, 17 years ago, we had received an order from Samsung C&T. It was the Busan new container terminal project. They requested us to install PVD up to 63 meters deep. At the time, 17 years ago, so tall PVD rig was not available. So Mr. Han, adventurous CEO, managed to fabricate the 65-meter high mast and organized the Hpji base machine. We succeed to install PVD up to 63 meters deep. As far as we know, it was the world record at the time. That is why I'm saying our achievement is big. Established in 1998, 24 years ago, and branch offices. Our deputy CEO is in Iraq now for DCM project. Now he's under trial mix design. More than 700 projects brought us a lot of clients, domestic and abroad. We collaborate with the research institute for our successful performances. These are our own equipment and manpower. Our recent record abroad and domestic and completed projects, more than 700 projects. These are our abroad projects in Egypt, PVD, Iraq, DCM, Kuwait, PVD, Bangladesh, DCM, Vietnam, PVD, sand drain, sand compaction pile, Singapore, PVD, Australia, PVD. In Vietnam, we did the part of Hanoi Haiphong Expressway, installed sand compaction pile and sand drain. Near Ho Chi Minh City, we did Yeonchak Power Plant project and Kaimep Container Terminal project. Because of traffic jam and for the further development, Vietnam constructs a lot of infrastructure at the Hpji river mouth, entrance of Ho Chi Minh City from the sea. CMIT Container Terminal project, 800 meter long and 600 meter width, 48 hectare. We install PVD. PVD install and slope protection dimnet. Yeonchak Power Plant project near the Ho Chi Minh City. Our company installed sand compaction pile at the first in Vietnam. Main portion install sand compaction pile, minor portion install PVD. They surprised very much when they excavate our sand compaction install area for their building works because the result was fantastic. 3 sand compaction pile rigs, 2 PVD rigs for that project. Deep in the Persian Gulf, Kuwait is located. They construct the seaport expressway railroad on the Bubian Island. Then seaport PVT installed. And this is causeway project. This bridge is 36 kilometers long. This bridge has 2 islands, north and south. Island reclamation and bridge works together. This portion, watered portion, is the excess pour water discharging portion, as soon as our PVD installed. In Egypt, near the Suez Canal, east port side industrial zone, we installed PVD, one section. In Singapore, we installed PVD, part of Changi Airport expansion project and Tuas Western Coast project and Jurong area. The most region of soft ground is the water. Of course, peat and rubbish also could be. The soil contains if the soil contains too much water, it looks like soup. When the water is decreased, it becomes soft cake. But when the water is dried out, it is turned to like stone. So most of all the soft ground improvement methods is focused how to treat the excess pour water. When you construct the structure on the soft ground, the water inside the soft ground start to be discharged during long time. The water, if 10 meter deep, should move 10 meter distance. But when you install drain material by 1 meter spacing, the excess pour water need to move half a meter only. Move short distance means discharge in a short time. Drain material, usually board type, and sometimes cylindrical type also. After clearing and grubbing, place the separation geotextile, place the horizontal drainage layer, install PVD or PCD, install monitoring instruments, staged embankment, considering the consolidation. Then the excess pour water move to drain board, then move to upside through drain material, then through the horizontal layer, discharge it outside of the structure. Sequence: attach the anchor plate at the bottom of the casing. Install, withdraw, anchor plate, hold the drain board, cut the drain board, and move to the next position. The monitor shows all the information to the operator: install depth, install force, verticality of the mast, location, install time, etc. Daily report. Vacuum consolidation is 넘어가야 될 것 같은데. Vacuum consolidation is a kind of drain method by the vacuum pump after PVD install and place membrane sheet. Vacuum atmospheric pressure is equivalent to about 3-meter high soil embankment. Individual type vacuum consolidation is sucking the excess pore water from the every cylindrical drain, so no need the membrane sheet placing. The procedure, vacuum consolidation procedure is install PVD and PCD, place membrane, operate vacuum pump. This photo is Vietnam Expressway project. Our company in Vietnam executed. This photo is port project in Vietnam. After install cylindrical drain, connect horizontal drain to the cylindrical drain. Operate vacuum pump. This is the individual vacuum consolidation site photo in Korea. Sand compaction pile rig combination is complex than PVD rig. Base machine is crane, generator for vibro hammer, air compressor, and wheel loader for sand supply in the casing by the skip bucket. Sand compaction pile advantages are increased bearing capacity and horizontal resistance to prevent the shearing failure during embankment, decreased consolidation settlement. Procedure is locate the casing. Usual casing diameter is 400 millimeter. Operator vibro hammer. Hammer is on the top of the casing. Penetrate the casing up to design depth. Supply sand into the casing by skip bucket through hopper. Check the sand level. Lift the casing 3 meters, then air blow out the sand from the casing and 2 meters compact down the 3 meter high sand pile. Then 400 millimeter diameter 3 meter high sand pile becomes 700 millimeter 1 meter high sand compaction pile. Repeat this procedure, accumulate sand compaction pile up to the platform level. Oscillograph of record. Vertical indicate the depth. Transverse indicate the time. Supply sand, casing install depth, vibro hammer ampere meter are recorded. When port sand is not available, we install by stone or gravel also. According to supply material, we call sand compaction pile, stone compaction pile, gravel compaction pile also. Deep cement mixing. Now the material is supplied by the skip bucket. And lift up. bucket is green. Deep cement mixing. After mix cement and water, slurry is prepared. Pumping slurry to the rig. The rig inject the slurry, mix with soil, and agitate. Procedure is after mix, design mix. After trial install, decide the cement ratio. Start, install DCM, locate and supply slurry, injecting, mixing, agitate according to the limited rotation speed. This is workflow chart. Vertical designate the depth. Transverse designate the time. Penetration speed, slurry supply quantity informations are recorded. This is QA checklist. DCM work. This is our DCM work in Bangladesh Matabari project. They construct the power plants. This is the drone view in the same job site. I'm going to show you the sand compaction pile project for your reference. In our country, as Dr. Kim explained, the West Coast Expressway is from Seoul to Mokpo, 340 kilometers long. Our country's geologic condition is east side is mountain area, west and south side is flat. So most of rivers flow to west and south. There are a lot of soft ground area along west and south seashore. The original design was by sand compaction pile and PVD. To shorten the construction period, they changed it to sand compaction pile and sand drain. After changing, we could reduce the construction period by 12 months. Because of PVD, consolidation required longer time. Another sand compaction pile example, Hanoi Haiphong Expressway in Vietnam. It was 105 kilometers long. Original design was PVD, sand drain, and long relief slab and soil cement column. They changed design from long relief slab and soil cement column to the sand compaction pile. This is the assumed soil parameter. Ibukota Nusantara. Dr. Lee brought this data from Indonesian Geotechnical Guide. After simulate the computer program, Dr. Lee have got those results. He assumed embankment height is 5 meters high, carriageway width is 15 meters width. Total treatment is 30 meters wide. You can compare the consolidation period, construction cost. We compared this cost by our Korean price. Considering the urgency, we propose sand compaction pile, sand drain, sand compaction pile combined method recommended. When we install sand compaction pile at the both sides of the road in the sloped area and sand drain in the middle, we can expect the early consolidation, reinforcement the ground, compaction effect, then brings the shortened construction period. But the medium high cost can create issues. These are our proposal. Now I'm closing my presentation. Thank you so much for a long time. Terima kasih banyak.
Thank you, Kamsiamida, Mr. Kang. I think this is very interesting material that we know in the Kalimantan, in the IKN, we have many problems with the soft soil. Based on our primary design for the toll roads, maybe we have to cut almost 30 meters, okay? And then we have to make embankment, but maybe only 5 meters. And I think we need some kind of the technology. I think this one can be a proposal for us, but we will, let's see, because the cost also is another consideration. Cost and time is become the primary criteria for us. But thank you, Mr. Kang, that he already give us the knowledge about the PVD, vacuum consolidation, sand compaction pile, deep cement mixing method in order to soft soil treatment improvement. Okay, I think for the next session, I think it's more interesting for us also about the Immerse Tunnel, because this is the new one for us. And then Mr. Jung will present two parts. One part is about the introduction, and the second part is about the application. So please, the time is yours, Mr. Jung. It will be 1 hour maximum.
Okay, nice to meet you, ladies and gentlemen. I'm Dr. Jung from Daewoo ENC. And first of all, I would like to appreciate all of you, especially Mr. Dennis and Dr. Kim here, to give a chance to explain our companies, Daewoo Engineering and Construction's sole and unique experience about Imos Tunnel. My presentation has three parts. And first part is general explanation and introduction of Imos Tunnel concept and principle. And these are table of content. I will explain through this agenda. So what is Imos tunnel? The tunnel is made of separate elements and each fabricated in a manageable length, something like 120, 180, depends on the project. And then having the end sealed with the bulkhead. We call this as bulkhead. So they can be floated to the water. The corresponding part of the path of the tunnel are prepared with the trench on the bottom of the channel being dredged and graded to the fine tolerance to support the element. The next stage is to place the element into place, towed to the final location, towing by tugboat. And once in position, additional weight, actually water, is used to sink the element into the final location. After being put into place, the joint between the new element and the tunnel, already installed element, should be emptied of the water, then made watertight by water pressure. This is a sequence of the construction of an Imos tunnel. Fabrication of tunnel element inside the dry dock. Dry dock is also used for shipbuilding. And after making all the element, the water filling inside the dry dock to tow out the tunnel element, the fabricated tunnel element. And next one, we move these elements to the temporary mooring area in order to install the equipment for the transportation and immersion work. And after completion of the installing the all devices, equipment, we're gonna transport to the site. And when it's got to correct position, there will be connection, and then backfilling, and after that, internal works and paving. So what is the benefit of Imos tunnel? We can minimize the required distance for alignment and land acquisition. For example, bridge should be long distance due to the navigation channel underneath the bridge, as you can see the below picture. And also boat tunnel should have long distance due to the required depth to have sufficient strength of foundation. But Imos tunnel, it can be optimized distance with the proximity of original seabed line. The last one here. And another advantage, we can say this is environmental friendly construction method without disruption of surrounding scenery. This is one example from Australia. The Sydney City has investigated the new bridge to disperse increasing traffic volume, but they found there is already two existing beautiful landmark scenery near there. One is Sydney Harbour River Bridge, and the other one is Opera House. So they finally decided to go for Imos tunnel. And other advantages are it can speed up construction and minimize disruption of the river channel if crossing a shipping route, and resistance to seismic activities, and safety of construction compared to working a dry dock as opposed to boring beneath a river or sea. And the final, flexibility of the profile. A basic concept of Imos tunnel is using the buoyancy. It's like a principle of submarine. Tunnel element is fabricated in land condition dry dock and transported with floating condition and sinking to the installation position and connected with pre-installed element as seabed line. And also water pressure is all the fundamental principle for the connection. The space between two elements, let's say TE5, tunnel element number 4 and number 5. After initial touch, the entrapped water will be here beside this two element, and one is already installed and the other one is newly installed. If we remove this entrapped water from the water pump inside, then the space between here, tunnel element number 5 and number 4, will be vacuum status. And then if we remove the water, automatically water pressure will be here. So it means water tightness can be achievable by natural water pressure if we remove entrapped air. So this is Gina joint shape at the end of bulkhead, around here, or around here, the surface. And then at the compression, it will deform like this. So this is the first procedure of water tightness, and there is another procedure, another step, omega joint here, the secondary joint, primary joint. The Imos Tunnel is not a new structure. The history of Imos Tunnel as follows. Imos Tunnel has more than 1 year of history and was built more than 150 times. First Imos Tunnel was waterway, not the roadway, in Boston, in USA, and has 79-meter length and 1.8 meter of diameter. First road tunnel, Imos Tunnel, was Posey Tunnel in USA to connect Oakland and Alameda. And first Imos Tunnel between country is Detroit-Windsor Tunnel to connect Michigan, USA, and Ontario, Canada. There's a lot of type of Imos Tunnel, type 5 functional tunnel, railway tunnel, road tunnel, and railway and road tunnel together. And especially railway tunnel has smaller section compared than road tunnel because there is no need to install the facility for ventilation. And another type can be divided by structural material of tunnel. And we can say there is two types of Imos Tunnel. One is European, the other one is American type. Most of Imos Tunnel in Europe is concrete structure, whereas the USA type is steel structure. And also Japanese type is also steel structure. And comparison of structural type can be divided by steel shell and concrete, which I explained previously. One is USA and one is widely used in Europe. And this is example of comparison of construction costs with another option of structure. The first one, example from George-Marsh Crossing, Canada. An Immerse tube tunnel will place the 60-year-old George-Marsh Tunnel on Highway 99 in Richmond, south of Vancouver. The Exit Tunnel was the first Immerse tunnel, Canada, when work started in 1957, with its depth below the sea level by dipping 20 meters into the Fraser River. And the new tunnel will feature two 4-lane tube placed in the river side by side, the same depth, but upstream of the existing tunnel. It will be very easy. Design consultant Koi, one of the excellent consultant for Immerse Tunnel and Bridge, planned and priced the operational and safety concept, construction method, and provide design, including quantity as basis for it. They compare 3 different options: new bridge and new Immerse tunnel and new deep boring tunnel. And they parallelly investigate 2 different concepts, actually 3 different concepts. The Immerse tube tunnel concept, like this, as shown in the here figure. And then long span bridge, cable stayed bridge concept. And then this is a table of comparison of construction cost. In this comparison, the estimated project cost of bridge was less than the Imos Tunnel, but I didn't include the boat tunnel because they were more than 3 times expensive compared than these 2 options. And another example of comparison is Irish Sea Link between UK and Ireland. Also, COWI planned the price same investigation, but this comparison is not fair because the route length is quite different. This is corridor 2 bridge option, and this is corridor 2 tunnel option. You can see the route length is quite different. Anyway, they investigated the board tunnel, not the Imos tunnel here, large diameter of 9 meters beneath the ground underwater. And very tricky high technology bridge in here. Pylon foundation with water depth up to about 165 meters, quite huge depth. And 7 main spans of 3.7.5 kilometer with a side span of 1.5 kilometer. Quite long bridge. I don't know whether this is feasible or not, but they already got preliminary design. These are comparison of the tunnel total construction cost, including the operation fee and so on. And this side is bridge fee crossing. The key is that each project has to be treated individually as conditions, requirements, and ETCs varies. So this requires a close discussion between owner, developer, and the consultant who carry out the study. And this is concluded remark of my first session. The benefit of Immerse tunnel is that they can be considerably more cost-effective than alternative option, such as boat tunnel beneath the water, being crossed or a bridge that will obstruct the water view. Second, the environmental location must be right through because there are many variables that engineer needs to consider when designing the Immerse tunnel. And the third, engineering is a key to designing the right tunnel shape and the structural system for the water crossing, geological profile, ventilation requirement, and the volume of traffic to be handled through the tunnel. And this is the end of my first session.
Please continue for the next.
Okay. Okay. And the second presentation will be, second and third presentation will be our okay, okay.
Then share screen again.
Again, okay.
The green bar, the green.
Remaining session will be actual instruction of our execution for Imos tunnel. Before starting up this presentation, I'm going to show one video which is self-explanatory for this project. It will take 15 minutes, around 15 minutes. Okay. Okay. Please enjoy the sound.
I'm sorry.
Sound.
Oh, I'm sorry. I thought that was the volume. Oh, this one. Oh, you have to open the first.
Okay.
이거 not Juni.
Escape first. Yeah, video. Oh, okay. Video open.
Global vision in the 21st century. The Dream Ocean Way linking Busan to Goje Island is nearing completion. The 8.2-kilometer long Busan-Goje fixed-link project consists of an immersed tunnel to be placed at an unprecedented depth of 48 meters, a 2-pylon cable-stayed bridge, and a 3 tunnel is made up of 18 elements that are each 180 meters long. Total length of the tunnel is 3.7 kilometers. It will be the world's longest and deepest immersed roadway tunnel. The cable-stayed bridges have curved diamond-shaped pylons, which is a world first. The Busan-Goje fixed link will be completed in 2010. Built for optimization and a safe design with long-term vision, will open a new era for linking the oceans of the world. The link has not used the conventional way of boring a tunnel in hard ground under the sea. It has employed the immersed tunnel method. All elements are precast on land, floated to the site, immersed onto a prepared seabed foundation, connected to each other by water pressure, and then covered by protection works. There is a 500-meter long, 200-meter wide dry dock at the Anjung Industrial Complex in Tongyang City, Gyeongnam Province, for fabrication of the immersed tunnel elements. Elements are concrete structures that make up the tunnel, built at an onshore yard. Each tunnel element, prefabricated on land at the Anjung complex, is a complete concrete structure 180 meters long. They are the world's longest elements and weigh from 45,000 to 50,000 tons each. The tunnel element is made up of 8 segments, which are each constructed in one continuous concrete casting with traveling forms specially manufactured for the project. This prevents early age cracking, and steam heating is applied for additional quality control.
To get a watertight and durable tunnel, it is essential to build it in high-quality concrete, free from through-going defects. This is because the concrete is the primary barrier against water ingress, and it needs to make tight connection with the joints. The concrete also protects the rebar from corrosion from seawater chlorides.
After fabrication of the tunnel elements, they are floated and transported to the site. First, the dock is flooded with seawater to float the elements. At the same time, water ballast tanks in the elements are partially filled through a pipeline to prevent irregular movements of the element during flooding. After flooding the dock, the elements float with their top surfaces approximately 30 centimeters above the water level. Buoyancy of the elements is controlled by adjusting the water inside the ballast tanks. The elements are towed out to a temporary mooring area to await transportation to the immersion site. Ground conditions between Gaduk Island to Jeongjuk Island, where the elements will be placed, consist of soft clay 20 meters in average depth. This needs to be properly prepared in advance of the immersion. First, dredging works are done to provide a seabed trench for the elements. Second, deep cement mixing and sand compaction piles are constructed for soil improvement of the soft ground conditions. Finally, a gravel bedding layer is constructed to make the foundation flat. In parallel with preparation at the immersion site at the mooring area, all equipment and facilities for immersion are installed, and the element is prepared for transportation by tugboats to the immersion site at Gaduk Island. In order to accurately predict the marine conditions during transportation, a local weather forecasting system has been installed at the site, the first of its kind in Korea. A 5-day period with waves less than 0.4 meters high is needed during transportation, immersion, connection, and stabilization of each tunnel element. Once this 5-day window is confirmed by the weather forecasting system, a decision to go for transportation and immersion can be made. Once the element arrives at the immersion site, it is connected to pre-installed anchors and wires to stabilize it against waves and the current. After increasing the weight of the element by increasing water in the internal ballast tanks, it is immersed under the control of a positioning system and adjusted by the connecting wires to its correct location. The new element is placed about 50 centimeters behind the previously installed element. After that, final connection work is prepared. At first, pulling jacks are installed between the previous element and the new one. Then, the tunnel is slightly lifted by a steel frame structure installed outside the element, called an external positioning system, to reduce friction force between the gravel bed and the underside of the element. Once the friction force is reduced, the element can be pulled to the connection surface of the previous element by pulling jacks. When connected, the rubber joint installed at the end of the new element is first compressed to seal a space between temporary bulkheads to prevent ingress of seawater. After confirming the first connection, entrapped seawater between the bulkheads is dewatered by opening the immersion chamber valve on the bulkhead of the previous element. While dewatering, the water pressure of the connection side decreases, and that of the rear side of the new element keeps constant. Therefore, this difference of water pressure between the two sides can eventually compress the rubber joints. After connection, the final correct positioning is done by the EPS. Then second rubber joints, omega seals, are installed inside the elements. Backfill and rock protection are installed to protect the tunnel against external impact, such as from a sinking ship, ship collision, and falling or dragging anchors. After dewatering and dismantling of the ballast tanks, ballast concrete is cast inside the tunnels to prevent uplift and movement of the tunnel. And all the construction activities are finalized by doing pavement works. Two cable-stayed bridges will be constructed connecting Busan to Goje. A 2-pylon cable-stayed bridge from Jeongju Island to Jo Island, and a 3-pylon cable-stayed bridge from Jo Island to Goje, which is the first of its kind in Korea. A cable-stayed bridge comprises pylons for supporting the bridge, a steel girder frame for the concrete roadway, and cables to connect the girders to the pylons. The pylon design doesn't follow the conventional H shape of the existing cable-stayed bridges in Korea, but has a curved diamond shape, which optimizes structural efficiency. Cofferdams, generally as big as a football field, are difficult to construct and can cause environmental issues in the ocean. The Busan-Goje fixed link has applied the precast caisson method, which is recognized as the most optimal method for marine construction. It is the first use of prefabricated caissons for sea-crossing bridges in Korea. Prefabrication of the structural works ensures high-quality control and construction safety. All parts for the bridges except the pylons are fabricated on land and transported by sea to the location. Concrete caisson foundations of the cable-stayed bridges are fabricated at the pre-casting yard. The heaviest caisson weighs 9,600 tons. It is partially prepared onshore and transferred by using a 3,000-ton marine crane to be completed offshore. Two lower parts of the caisson, which weigh 2,600 tons, are fabricated at the yard. Each of them is moved to the offshore yard by a marine crane. The two lower parts are connected offshore by building the upper part of the caisson. Caisson transportation has utilized the natural buoyancy of the open-celled grid structures. By floating them, the weight is shared between the water and the 3,000-ton crane. Hence, the caisson can be moved by the marine crane onto a floating dock for the 35-kilometer-long journey to the site. The ground has been excavated to reach a sound soil layer to support the caisson foundation. 3 precast landing pads are placed on the formation layer, ready to receive the caisson. The caissons are sunk using water ballast, which is later replaced by rock ballast once they are in place. Once a caisson is positioned on the landing pads, grouting is carried out to fill the gap between its underside and the seabed. Grout materials, a mixture of cement, gravel, etc. Trench flaps made of a geotextile membrane are installed at the edge of the caisson to stop cement washout. The flap is enough to stop the current and debris and makes for still water conditions below the caisson. This helps the grout to fill all voids between the underside of the caisson and the seabed. This is called the underwater grouting method. Large-scale tests were done to ensure that the caisson grouting would work. Apart from the grouting method, the Busan-Goje Fixed Link project has introduced a whole range of new construction technologies, such as the precast construction method to fabricate, transport, and install the caissons. This opens a new chapter for sea-crossing bridge construction techniques in Korea. After completion of the caissons, pylons are made from in-situ concrete, and then cables are installed from the pylon to decks. The bridges have unique and beautifully curved diamond-shaped pylons. This unique shape requires fine and accurate construction methods. Apart from aesthetic aspects, the diamond-shaped pylons also have the structural advantage of minimizing the size of the caisson and of improving aerodynamic stability of the cable-stayed bridge. Once a pylon is constructed, the deck and cables are installed. A floating crane lifts the pier table onto the pylon crossbeam, and it is then fixed to the pylon with cables. Derrick cranes are then installed on the deck to lift the girder frames and concrete deck panels. A derrick crane lifts each 12-meter-long steel girder frame into position. It is then fixed to the previously installed steelwork by bolted connections and to the pylon with inclined cables. Once the frame is connected, the derrick crane lifts and installs 6 precast concrete panels. This superstructure segment erection work is carried out alternately from the center of one pylon to both outer sides and is completed at the middle of the main span after connecting the key segment by bolting. Roadway pavement, lighting standards, and safety barriers are then installed as finishing works. A wide range of advanced civil engineering technology has been applied to the bridges to cope with the marine situation, such as the floating deck system. This means the deck is supported by cables, not by bearings on the pylon crossbeams. This is a newly developed method to improve structural efficiency and safety. The approach bridges have also used precast construction methods for caissons and pier shafts to minimize works in the open sea. Full-span 90-meter lengths of prefabricated deck sections are erected by a floating crane, ensuring high-quality control and ease of constructability. The Busan Goje fixed-link project has employed a high-tech durability design to meet more than 100 years of service life. The concrete used has high durability against chloride penetration compared to normal concrete. The cable-stayed bridges of the Busan Goje fixed link are environmentally friendly structures that have minimized marine working problems by using advanced construction technology. They will harmonize with the beautiful skyline of the neighboring islands and be a landmark on the southern coastline. The Busan Goje fixed link project has prepared well for various risk factors that may occur under and over the open sea.
부산 거제간 연결도로 침매 터널은 높은 수와 지진, 선박 충돌 등의 극한 상황에서도 그 기능을 유지할 수 있도록 설계되었습니다. 또한 진보된 개념의 지방 계량 공법을 적용해서 장기적인 침하에 대비하였고 터널 내부에서 발생할 수 있는 차량 화재에 대해서 터널과 이용객들이 안전할 수 있도록 계획하였습니다.
The southern coastline of Korea has a large volume of seagoing traffic, including container ships, gas and oil tankers. Militarily, it is an important and strategic area. The overall design of the Busan Goje fixed link project considered loadings from impact and sinking of a 50,000-ton vessel sailing to a neighboring port. A particular safety measure is that the minimum clearance from sea level to the top of the tunnel's rock protection is more than 20 meters, which is well in excess of the 15-meter maximum draft of a 50,000-ton vessel. Even if a large vessel deviates from the navigation channel, it can be controlled by the Emergency Observatory Center with an advanced warning system so that all possible risks are well prepared for. In the event of a fire, the Immerse tunnel structure is designed to be safe at a temperature of 1300 degrees Celsius. And emergency accesses are provided every 90 meters along the tunnel to give drivers a safe evacuation route through the central service gallery. In addition, an intelligent traffic system and supervisory control and data acquisition system will cover the whole line of the project to prevent human casualties and to provide early warning of fire. The Busan Goje fixed link was also designed to safely withstand seismic load, so no traffic problems are expected, even after a strong earthquake event. Furthermore, the entrance level at the tunnel portals is designed to be high enough to be above the effect of flooding from large waves, storms, and global warming.
The bridge has been designed for the most severe cases you can think about, for earthquakes, wind, typhoons, ship impact. You have a ship channel, you have ships going underneath the bridge, and of course big waves. Those things are all considered in the design to make the bridge as safe as any road in Korea traveling on in its final state.
In 2010, when the project opens, the journey time from Busan to Goje Island will be reduced from 3 hours 30 minutes to 40 minutes. And it will form a U-shaped connection by the Daejeon-Tongyang Expressway and Daegu-Busan Expressway, which will be a main artery for international logistics.
チンマイトンネルは海底トンネルを建設する方法の一種ですから、例えば韓国と日本の間、あるいは韓国と中国の間の海底トンネルを建設するのに参考になるでしょう。したがって我々は今後ともこの工法が韓国の役に立つよう願っています。
The Busan-Goje Fixed Link is recognized as a significant international project in heavy marine construction that has provided the opportunity for Korea to increase its construction expertise to the global standard. The Busan-Goje Fixed Link will become a main artery to link logistic routes in Northeast Asia and is a result of Daewoo's continuous innovation, challenges, and passion.
Did you enjoy? I hope you enjoyed the video. So the second presentation is introduction of Busan-Goje Fixed Link. You already seen from the video. From here to here, the Imos Tunnel. There is a portal coming into Imos Tunnel, and there is another portal going out and connect to the bridge, and 2 cable stayed bridge and 3 cable stayed bridge here. You already seen the composition of our project, Imos Tunnel, 2 cable stayed bridge and 3 cable stayed bridge. Total length of our project was 8.2 kilometers. This is the organization. So Busan Metropolitan City and Gyeongnam Province, we have Busan-Goje Fixed Link authorities, and SPC, under the SPC, we were the main contractor, and the design checker in Europe and Acadis, and all other international designers and subcon and supervisor. So overall length 8.2 kilometer, bridge 3.5 kilometer, and Imos Tunnel 3.7 kilometer, including the curtain cover, and portal and ramp 1 kilometer. 2 road lane each way, 1 central service gallery. And our construction period was 72 months, 6 years. And operation period is 40 years. So total investment was 2.0 billion USD, including the escalation. Then private investment was 70%, and remaining 30% with government financial support. The number of elements was 18, and the length of one element length is 180, and it weighs 45,000 tons per each element. And cross section width was 26.4 meter, and the height is around 10 meter. And I will skip this slide. You already seen. And this is also bridge layout. And also you've seen this construction sequence. I will skip this one. And these are key features of our Busan-Goje Fixed Link. Immerse Tunnel was first application in Korea, including 3 pylon cable stayed bridge. And we applied the fast track procedure to minimize the design and construction period and saving the cost. And there were 2 local governments cooperate, Busan and Gyeongnam Province. And we face severe construction environment, such as deep water depth,
the maximum 48 meter, and offshore marine condition. Normally, Imos Tunnel were built in near the river, where there is no big waves and no big tide. But here, the location was very severe. High waves and strong current, and thick and soft marine clay. The maximum thickness of clay was 35 meters. And earthquake. And we applied the new construction measures such as Directorate for durable concrete technology and high accuracy gravel bedding. Our required tolerance was plus minus 40 millimeter under the 48 meter water. We succeed to achieve 25 millimeter. And external positioning system. We developed a device for external positioning system of Imos Tunnel. This is international patent. And curved diamond shape of pylon. Those we are developing in here. The design basis was Ashito LRFD, and site characteristics are direct exposure to South Sea of Korea. So there is strong wind, including typhoons, and associated high waves. And there are many large ships between the Busan harbor and South Sea. And we need to consider the road for the actual site conditions, such as wave, wind, ship collision, and seismic, and so on. And fabricate 5 elements at the same time in the dry dock. And element consists of 8 number of segments and fabricated by the segment. And between the segment, there is a shear key. And use a prefabricated traveling form instead of conventional form, because there should be no stopping of concrete. So continuous concreting from bottom slab through the wall to top in order not to make construction joint. If there is a construction joint, it's going to be hole penetration deck crack from the depth of the wall, the thickness of the wall. There should be no construction joint and there should be no cold joint. So we call this as monolithic method, the continuously concreting from bottom to the top. It took almost 40 hours to complete the concreting for prefabrication of one segment. And rebar assembly and concreting, as I explained. And this is internal form and outer form. And this is concrete placing sequence, concrete slab, bottom slab, and concrete wall, and top slab continuously. It should be continuous. And I will skip very quickly because you already seen the sequence from the video. And mooring. And this is special equipment for external positioning to have a final position and fine adjustment of the location of element accurately. And the element equipped with all necessary temporary facility and was towed by tugboat to the location where the element was placed on. The important thing is the weather and marine conditions, such as wave height and current, should be taken into account, making decision go or no go. We are allowed to go under the 0.4 meter wave height. So we established the weather forecasting system, and it was operated during the construction whole time. And this is the wire system to make a correct position and adjustment for the immersion. And this is variables, a lot of equipment, joint and push pulling jack and monitoring sensors for the immersion work. It's not easy. The concept is very easy. By water filling inside the water tank, ballasting tank, and it can be synced to from the pontoon. And then connection, as you can see in already video, and backfilling. And final one, internal work. And also there should be fire protection to not to make the harm damage on the concrete where there is a fire. And I will skip the cable stayed bridge very quickly. Yeah, this is concluding remark of second part of my presentation. Busan-Georgia Fixed Link is first Imos Tunnel project in Korea. We overcome the severe weather condition, open sea, high waves and strong wind, ship impact, earthquakes, and so on. 2 hours of travel time reduction between Busan city and Georgia Island was achieved. It was reduced from 140 kilometers to 60 kilometers after construction of Busan-Georgia Fixed Link. And we can have 400 million USD yearly saving effect of total logistic cost due to this project. Yeah, this is end of my second presentation. And this is my last presentation, which is being executed in Iraq. The name of project is Khor Al-Jubair Imos Tunnel. Iraq is a country in Middle Asia, surrounded by Saudi Arabia, Iran, and Turkey here. The capital is Baghdad, and official language is Arabic, and land area is here. And this is Qasr, our site is here. And this is Basra Airport to our site here, 92 kilometers. And we are building this connection road and Imos Tunnel here and new port project in here. There are several projects in this area. Total 5, as I explained previously. And this is project overview of Imos Tunnel in Iraq. Project name is Khor Al-Jubair Imos Tunnel. And approximate cost is 634 million USD. And length of Imos Tunnel is 1.2 kilometers. If we include the cut and cover and open cut at graded, it's gonna be 2.8 kilometers. We have 6 lanes, 3 lanes per each direction. And depth is 20 meters from AFGP. AFGP is the level from general port. So we have 10 meters, 126 meters of 10 element, which has 34.58 meter width and 11.05 and 9.85 meter height. There is a 2 different way the height because the deepest part and the shallow part. We have similar case in here. And those are our main works and material. And this is general layout. A special thing is the fabrication yard is located here. after fabricating whole element, and we will move to the fabricated element through this line, and one by one, and we will connect, and finally it shows like this. And this is summary of construction plan. East cut and cover excavation, and structural work, tunnel element fabrication, and soil treatment. We are going to use DSM by June Construction Company, and dredging and Imos Tunnel, backfill and rock protection, and other service building, pavement, MEP work. This shows the section of the Imos Tunnel, and we have two types of Imos Tunnel section. One is shallow part, the other one is deep part, to optimize the concrete quantity. And then ground improvement and earthwork. Here, soft clay will be improved by DCM, and backfilling with rock protection. And here, two parts from here, 8 trench dredging. And finally, lighting, ventilation, and firefighting work will be done. And this is fabrication layout. It is already completed. We are going to plan to fabricate 10 elements at one time. After fabrication of a whole element, we're going to remove this wall, and we will move to this element through here. This is alignment of Immerse. This page shows the actual site condition, completed fabrication yard. And this page shows another construction progress. This is also work for Alpha side and budget plant and so on. And this is East cut and cover area excavation, which will be the portal of the Imos Tunnel. And this page shows the section and cut and cover, tunnel element, and open cut. And structural sequence is more or less same with others. And this is amount the soil treatment drawings. A huge amount of soil treatment is required. This is a sequence of soil treatment work and site equipment. This is very similar, which was shown in June Construction's presentations. And dredging work. We're going to dredge through the channel, which is required for accommodate the backfilling and Immerse tunnel installation and so on. And immersion work sequence. We are going to connect through this sequence. And immersion work, this is part of the video you already seen. And after immersion, the rock protection section is like this. The actual status of progress of our project is 7% at this moment. As of end of May, it's a very beginning stage. And this is the final end of my presentation. Thank you for your attention. Thank you.
Thank you, Mr. Jong. Very nice presentation. And I think we already hear about the process of the construction of the Immerse tunnels, and also the criteria and the advantage and disadvantage of the Immerse tunnels. For the audience, in fact, we are in Directorate General Bina Marga now try to plan for the Immerse standards in new IKN in Nusantara, Ibu Kota Nusantara. We will start the study this year. We hope within the next year we can construct the Immerse standards. And also we are maybe join with the Korean government. And another is we are in processing of the study with the Netherlands government in the Trans Sumatra toll roads. So I think the knowledge of Mr. Jong will be very important for us in order to improve our knowledge and our experience in the Immerse Tunnel field. I think for the webinar is already completed. The speaker already present their material ranging from the soft soil treatment until the advanced technology of the Immerse tunnels. So I think now is the time for the question and answer. I think the time it will be, we still have much time, I think almost 1 hour. So I will give you to the audience directly, please. Bentar dulu yang ini dulu. Ada nggak ya gitu. Please, you can raise your hand if you want to speak directly. Ya pakai benza nggak apa-apa Pak. Tapi sebelumnya Mr. Kim, you will add something?
Me.
Oh, you, Mr. Chung, please. Mr. Chung, please.
Thanks again to give this good opportunity to explain our experience about Imos Tunnel. So I would like to invite, if you have interest, to visit our site. So there will be good experience to see how we are operating and how we build the Imos Tunnel, including the cable stayed bridge. So if you want, please let us know, okay?
Thank you, Mr. Jong. In fact, we are in Directoral Jenderal Bina Marga. We have planned to visit some location. We are already discussed with the Edi Radian as a Director General. Maybe we will visit in some location in Europe, maybe also in Korea if possible. We will report this to our DG as well.
Okay, thank you.
Okay, so if there is any participant to directly ask the question, please raise your. Silakan Bapak Ibu kalau ada yang mau bertanya. Saya pikir ini kesempatan bagus ya untuk kita sharing, Pak.
Izin Pak Dedi.
Silakan Pak Dir, Dir JBH, monggo Pak.
Thank you Pak Jeong for your presentation. I just want to request the question regarding the cost. You said that the Immerse Tunnel compared to bridge from 200 to 300, yeah. What you mean this is already including the approach tunnel to Immerse Tunnel, or just Immerse Tunnel compared to the bridge?
It was only comparison with the defined length of Imos Tunnel and same length with bridge, not including the approach tunnel or approach road.
Oh, okay.
Actually,
So
it was prepared by COE, design consultant, not by DEU. So I quote from them.
So if totally with the approach tunnel, it's become.
Sorry?
Because I think the is complete with the approach tunnel. How much for this?
Including the approach.
Yeah.
Including approach. Maybe all the tunnel approach. Yes.
Yeah. So it's difficult to say which one is better. It depends on the various site condition, and there should be a lot of consideration, weather condition or geotechnical condition.
Yeah, okay. Yeah, because when you calculate for the cost of bridge, including approach, right, from the land to the land, another land. But if compared to Immerse Tunnel, you only the Immerse Tunnel first, not including the tunnel to the land. It's quite confused for the cost. And then second one, I want to. I'm sorry, this. How effective the depth of the clearance depth of the top of the and top of the Immerse Tunnel for the
water depth.
Yeah, I think the totally height of the Immerse tunnels maybe around 10 meters, right?
It depends on how many ships and how big ships is operating near the Immerse tunnel. So we applied the 20 meter in GK project, and also the 20 meter for Iraq Immerse tunnel, because we considered the 50,000 tons of capacity of ship navigation channel. In that case, 20 meter was enough.
Okay. Okay, Pak Dedi, Pak Jong, thank you.
Thank you.
Terima kasih Pak Direktur. Mungkin ada yang lain, silakan. Sebelum saya baca yang ada di chat.
Pak Dedi.
Silakan.
Yeah. When we built the Immerse Tunnel, how far we consider about the condition of the existing the seabed? You know, as you explained that the Immerse Tunnel needs or require the say flat bed of the sea.
Seabed,
yeah.
right?
Yeah, seabed. I mean, and you need a seabed. Just in case that the condition is not so flat, or what is the limitation? Maybe you can explain how we solve that problem.
It is better to follow original seabed line.
Yeah,
not
of course.
excavate too much, not fill too much. The concept of Immerse tunnel is something like this. When we excavate, the amount of the material, similar weight of Immerse tunnel. It means if we build Immerse tunnel, the same amount of the soil will be removed, and we will install the same weight of Immerse tunnel instead of dredged soil. So it's gonna be same weight to the ground. Yeah, same seabed line and same seabed weight. There will be no further loading. That is the concept of Immerse tunnel. We will maintain same weight as original. So there will be no further excavation, though there should be, but instead of the excavation, we can fill a little bit to make a smooth seabed line, or we can excavate further. It depends on bathymetric survey and seabed line. Yes.
Yeah. So we need really to check very detailed about the seabed condition.
Correct.
Okay.
Yes.
Thank you, Pak. Thank you.
Terima kasih Pak Danis. Yang lainnya satu lagi silakan.
And I found a lot of questions from the chatting.
Yes, I think there are many questions.
Okay, so I will try to explain as much as I can. The lifetime of design can be 100 years is normal. And also we can design 200 years, of course. And what kind of method used to calculate the soil estimate? Actually, I'm not expert for soil. I'm expert for structural, so I cannot. It's difficult to answer. And there is another question regarding the environmental friendly. So of course, there must be the damage of existing mangrove forest, and we had a similar situation in Mumbai, India, where we are building the bridge. So the Indian government decided to recover the same amount of mangrove due to the construction of bridge to another place. So it's a responsibility of there was a responsibility of the government when we made a contract between them. So it's kind of policy. If we need some amount of damage of, if we expect, then same amount will be recovered to other area, or something like that. It's inevitable anyway.
I think there are some question, another question. I think there is from Malaysia. Yeah. How does the Immerse tunnel resist the earthquake as compared to cable style bridge? Yes.
How does
The design.
the Immerse tunnel resist
Construction
the
period.
earthquake
Yeah.
compared to cobble stayed?
Yeah.
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 The earthquake.
Earthquake,
Yeah.
design of earthquake is same. So we are applying the same magnitude of required magnitude of earthquake in that area. One for bridge, one for Imos tunnel. It's not different, the same.
Yeah.
It's the same. Yes.
But which one will be more resistant?
Yeah, it depends on the safety margin when we design. But I can say it depends on the geological condition. I can say Imos tunnel is better. If there is any risk of liquefaction behind the geological condition, so it's better to have Imos tunnel. I know you have concern about earthquake. This area is a severe earthquake location.
This is another question. There are two questions. First, when we use Immerse tunnel, did we need to do any special kinds of foundation, seabed, or soil treatment before tunnel's element placement? And number two, when we do the backfill on top of the tunnel, did we use surrounding soil for it? What about the tunnel connection anchored to the sea, to the seabed, or it just need its own and then backfill wake?
What was the first question?
The first question is soil treatment.
Soil treatment
On the bed.
Conventional soil treatment such as SCP and DCP can be used for the soil treatment. And second question, after installation of Imos tunnel, the first layer of backfill will be rock fill.
Oh.
And then second layer and third layer will be armored stone. So that is commonly used material for the backfill of Imos tunnel. The weight will be something like 1.1 times of original weight of a seabed after installation of after backfilling of a whole armored core and rock fill. More or less same with the original concept.
I think so many questions. Yeah, so many questions mostly related to Immerse tunnels. Yeah. One one interesting question is about, is there any instrument installed to record the settlement of seabed during and after construction?
Basically, there is a requirement for the differential settlement and global settlement. So when we design the Imos Tunnel and when we design the foundation, those requirements should be adapted to the design. So finally, there will be no monitoring system. Monitoring system can be installed between the joint. The joint can be opened. There is a tolerance, open and differential settlement. There is a monitoring sensor between the joint where we are now to see where we are now. Yes, where will be the rotation and where will be the settlement. We are monitoring, but until now there is no significant movement.
Actually, joint is the weakest point in the structure, so that's why they have to install the monitoring system. Yeah.
So as I explained, the Imos Tunnel is not a one structure. It divided by 18 number of, from Busan Project Fixed Link, we have 18 number of segment, and one segment consists of 8 element segment. So it's like a snake. There will be opening and the gap requirement from the element, from the segment, between the segment and between the element. Yes.
Because we can expect a very strong like typhoon wave and whatever that it should be flexible, otherwise it will be broken.
Yes.
So you explained that there are two kind of the structure for the Immerse tunnel, steel and concrete.
Yes, correct.
So what's the standard core that we can use? Is there American standard for the or
the cost point of view or code is not a big issue. We can apply Eurocode, we can apply the Ashtor RFD. Busan Project Fixed Link, we applied Ashtor RFD, whereas Iraq, we applied the Eurocode. Because the Iraq area, they wanted to use the European code. Yes.
Is there any criteria or just? There
is no special criteria for Imos Tunnel itself. We apply the various structural code, which is the structural and steel, something like that.
SI unit and pound unit.
The cost, as you can imagine, concrete tunnel is cheaper than steel tunnel. Yes. But the technology should be issued, concrete technology, such as the durability design and concreting technology, to prevent the penetration crack through the depths of the concrete. That is the key issue. Water tightness, also the quality control of concrete is the key issue.
Okay, and then for during the preparation, I mean, let's say during the feasibility study or the detail engineering design, what's the survey should we conducted? Let's say for the soil investigation, what kind of the soil investigation should we do?
Normal geotechnical investigation is enough. The same concept we are applying in investigation of bridge, foundation, the same concept. There is no specific requirement for the geological investigation. The same concept we are applying.
Is there any, let's say, for the tidal investigation or?
Yeah, of course, there should be tidal and wave and wind. Since this is very critical for the immersion work.
During construction stage, once you complete You don't need that much information about the tidal and water.
The final stage, it is underwater, underwater. So there will be no significant impact.
So what's actually the most difficult from designing to the conditions? It's on your experience. What's the most
from my experience of Busan-Goje fixed link, it was weather. We were fighting with wave. We were fighting with wave for Imos Tunnel, and we were fighting wind for the bridge construction. No. We need to fight with wind for the bridge construction. We need to fight with wave for the Imos Tunnel construction. Yeah, wind is critical for bridge. Wave is critical for construction of Imos Tunnel. So it's lucky. It's a good condition.
There are another question. First is how we are cope with the earthquake and the tidal wave.
How we are complete or
cope. The effect of the earthquake and the tidal.
There is no special method to reduce the impact of earthquake. If there is a design criteria for that area, then we need to design as it is. It's not a big deal. Yes, we can overcome by design. Yes.
So during design we are considering that one. And in which condition that Immerse tunnel is not feasible to be built?
Open the sea condition. It's not feasible. But we need to build.
Why?
As I explained, we should face high waves, high wind, high tidal condition. Weather condition is govern the critical stage of Immerse tunnel construction, and also water depth. So if your site is very calm and shallow, it could be good condition, very easy to accommodate the Immerse tunnel.
Yeah, for your experience, if we want to, let's say, conduct the feasibility study, how many months we need? Let's say for 1 or 1.2 or 2 kilometer of the Immerse tunnels.
At least 6 months.
At least.
Because there should be a lot of investigation, bathymetry, and the geometry, and the geological and environmental, and so on.
Is it including the basic design or just a concept design?
Concept.
If it is included the basic design, how many months?
Oh, it's difficult to say. If we include the basic design, it's gonna be a double maybe.
It depends on how you get the geotechnical information from the site.
Properly, yes.
Environmental.
And another issue is about the dry dock or casting yard. What the requirement? Yeah, the requirement about the area and the distance to the project.
When I consider your project location, the most concern is foundation condition, foundation design, and soft soil treatment for the construction and preparation of prefabrication yard. It will govern the design. And we need to find the proper location. And Busan-Goje fixed link, we applied a remote distance of prefabrication yard because there is already existing shipyard dry dock. We utilized, but Iraq Imos Tunnel, as you can see in my presentation, the fabrication yard is very near the Imos Tunnel line because we don't have any proper location nearby. So we applied very near fabrication yard location. Yeah, it depends on the logistic plan and depends on the planning and design. The creative solution can be made. Yes. Yes.
It seems you have already completed construction of the Immerse Tunnel in Indonesia because you got all the information knowledge.
Ya, mungkin Bapak Ibu nih pertanyaannya memang banyak, cuman ada beberapa yang sudah ditanyakan seperti masalah kos tadi kan sudah ditanyakan juga.
Di luar lagi enggak? Ya.
Cuma ada, saya undang teman-teman Belanda.
Ada nggak itu dari PSU?
Ada nggak? I invite the person from Tunnel Engineering Consultant. I think join or not today. Maybe somebody from Tunnel Engineering Consulting can give comment or any experience.
China, you don't have many tunnels in Indonesia, right? Number of tunnels in Indonesia. Just few numbers.
There is boat tunnel. Boat tunnel.
We have 100.
Yes.
100
Yes.
tunnels.
Arjun.
Mr. Kim from Korean Exim.
Maybe from the Korean Exim Bank, Mr. Kim. Is there any additional information from Mr. Kim? If
From Mr. Kim.
Mr. Kim.
Yes, I'm here. I'm listening, but I do not have any additional comment. I had while listening to the presentation. Thanks for this valuable opportunity. It deepens our knowledge on Immerse Tunnel. So we are expecting our grant facility to implement the feasibility study.
Thank you, Mr. Kim. We want to expedite the process.
Sure.
If possible, next month we can start the project, Pak Kim.
Yeah, let's collaborate to shorten the period 1 month. So next month.
Okay, thank you. Mungkin Bapak Ibu dari akademisi, silakan Bapak Ibu. Mungkin dari saya nggak tahu nih, dari konsultan FS-nya BPJT mungkin ya. Ini silahkan teman-teman sekalian. Nggak ikut ya? Atau dari BUMN silahkan Pak. Dari Utama Karya, Waskita, atau Wijaya. Berantas. Berantas silakan Pak. Kalau ada yang perlu dipertanyakan. Oke, Bapak Ibu, masih ada lagi tidak? Saya kasih kesempatan. Baik, karena begini Bapak Ibu. Silakan.
Sorry Pak Dedi,
Silakan.
Pak Aryan join Pak dari Tech Engineering Consulting.
Oke.
Hallo.
Hello, guten Morgen.
Goedemorgen.
I think it's the morning in Netherlands. Yeah.
Ja,
Can you give
goedemiddag
any?
voor you.
Goedemiddag. Goedemiddag. Can you give any comment or any sharing knowledge about the tunnel experience?
Yeah, what do you mean in general? We have been involved in immersed tunneling for the last 30 years. In general, I can say that our company is from the Netherlands, and that we have over, I think we have more or less 35 immersed tube tunnels in the Netherlands. So from that, we build a lot of experience. And at the moment, we are constructing our last immersed tunnel. It's in Rotterdam. 2 immersed tunnel elements. They have been floated 2 weeks ago, and they will be immersed, I think, early next year. So that's our latest immersed tube tunnel. We are currently also working in Belgium, very close to us, also on an immersed tube tunnel. Yeah, and why do we have those so much immersed tube tunnels? It's because of our geological and geotechnical situation in our large harbors where large vessels need to enter. So in that conditions, when you have large ships and small rivers, most of the times an immersed tube tunnel is the most cost-efficient way to cross the river. And we're also looking at Indonesia, and I think at some locations, an immersed tube tunnel might be a good solution. In general, you can say when you are close to the ocean, close to the sea, where you have big vessels, then an immersed tube tunnel can be competitive. If you are very far into the land, where the rivers become small and the ships become small, then usually a bridge is cheaper. So for your new capital, it does make sense to have a look at an immersed tube connection. You always need to view in detail. If it's the best solution, cost-wise, environmental-wise, technically, but you need to consider. I think at the moment, worldwide, it's not a technique which is used very often. You much more come across bridges and TBM tunnels. So therefore, it's a special technique which is not known to all consultants or all contractors worldwide. Also, clients not always know about the technique. But currently, worldwide, there are a few tunnels under construction. Fehmarn Belt is, I think, the most famous one between Germany and Denmark. They are currently working on a tender for an immersed tube tunnel in Sydney, Australia. I think in Germany they are thinking about an immersed tube connection. Hong Kong just finished their Satin to Central metro tunnel with an IMT. China has a lot of IMTs under construction. I think China, they will soon have more IMT connections than the Netherlands. I think you discussed already, but also in Vancouver, Canada, they are thinking about a new George Massey crossing. So putting a new IMT next to the old one. I myself was involved in an IMT connection in Mexico. That's the first in Latin America. And also in Brazil, there are a few connections where they are thinking about an IMT. So I think it's a connection which is getting more known worldwide. And for Indonesia, it's also a good thing to have a look at because no high-tech solutions are required. You can make it with conventional reinforced concrete. So that's something Indonesia local contractors can do very well. Maybe the immersion is a little bit special, but that's only a small part of the complete design. So I think for Indonesia, it makes sense to have a look at immersed tunnel connections.
Okay, Mr. Aljan, I want to ask about what the critical factor during the preparation and construction the immersed tunnels, and then the second thing is what the problem or issue that we will face during the operation and maintenance.
Okay. Yeah, most critical during construction, you are making a reinforced concrete box, which a lot of contractors have experience with. But the box, the concrete box, will be located underwater at 10 or 20 or 30 meters of water pressure. And then it's very important that the concrete is watertight. And most leakages occur in the outer walls because first you cast the concrete slab, and then 2 weeks later you cast the walls and the roof. And once you cast the walls on the floor, you will get concrete shrinkage. And because of the shrinkage of the walls, you will get cracks in the walls. So it's very important to control those cracks in the walls, because if you have those cracks and you put it on the water, then you have leakages. And you can do by, for example, cooling the concrete in the walls, or you can do by putting more reinforcement in it, or you can do by have a special look at your concrete mixture, or you can do injections after casting of the concrete. Most of the times it's a combination of a few of those 4 options. I think that's a critical item during construction of the concrete. Furthermore, it's just a normal concrete box. There are some special features required. So you have the joints between the tunnel elements, which is a rubber seal. You will mount that rubber seal on top of a steel end frame. It's important that you have very tight tolerances on that steel end frame. Otherwise, the IMT elements will be not in the right alignment after immersion. So I think that's 2 critical items. And then going to your second question, that was about maintenance during operations phase.
Yes.
The most important things for during operations is your installations, I think. It's the ventilation, it's the fire systems, the lighting in the tunnel, your pump installations. When you're considering maintenance, then that's where your primary focus is on. So furthermore, your concrete structure, it's concrete, and if you did it well, if you did a proper job during construction, then there are no leakages. So there's not really anything to maintain. What we usually do is measure the chloride penetration in the concrete and see if corrosion of the end frames or corrosion of the rebar starts. And for older tunnels 30, 40 years old, you sometimes see start of corrosion, and then you can do a cathodic protection. But most of the times when we look at old tunnels, then there's hardly any corrosion because there's no oxygen coming on the outside of the tunnel elements. So maintenance is all about your installations in the tunnel.
Okay, thank you, Mr. Arjen, for the sharing.
Yeah.
We keep going on the Jambi Immerse Tunnel, yeah?
Yes, we're looking at it.
Yes. What about the progress of the study of the Jambi Immerse Tunnel?
Yeah, we received your bathymetry and topography.
Okay.
That's the most important starting point. How deep is your water? And what levels do you need to connect to at the land side? Furthermore, it's important how many lanes do you want to cross the river with? So currently we have 2 times 2 lanes. In between, there's usually a central gallery to provide a safe space for escape and to provide a location to put your cables in.
Yeah, our technical advisors.
So what we did is prepare some draft sketches of the longitudinal alignment that determines the length of your tunnel. And we want to show next week, we want to show you those draft sketches, because it's easy to talk about the connection when you have a drawing. And what is important there is, of course, in the end, the question, is it a good option to do an immersed tube tunnel? Well, as I said in the beginning, it's important to have large ships. If you have large ships, then an IMT is usually the cheaper option. But I think at that location at Jambi, the ships already become a little bit smaller. So then a bridge might also be an option. But we will try to come up with a cost estimation. And I think there's also a design for the bridge already on the table, so that we can compare which option is the best one cost-wise. Of course, we in Jambi also have the environment. Maybe there are mangroves. You have, when you're doing an immersed tube tunnel, you need to have some dredging. And when you're going to do dredging through a mangrove area, that's in the beginning, it's not a good idea. But once you compare to a bridge solution, a bridge needs pillars as well. So a bridge will destroy the mangroves as well. You also need to consider the blockage of the river. If you're making a bridge, then the pillars will block the flow of the river. And in the beginning, it doesn't look like that's a lot. Yeah, but actually, if you have 10 pillars in the river, then there's maybe it's a 10% blockage of the river, and that will maybe cause problems upstream when you need a lot of Yeah, when there's a lot of rain, you want to have a large discharge, and that's blocked by the pillars. So a tunnel doesn't have that problem. The tunnel has the problem that it needs to be long enough that the entrances are not in the area where the water is during flooding. So maybe then the tunnel becomes very long. So for Yapi, we're trying to solve it by making a kind of entrance island where the water can flow around when there's high water. When there's no water, you can just come out of the tunnel without problems.
Okay, thank you. Thank you. I think we can discuss later about the Jambi Immerse Tunnel ya.
Yeah, interesting.
Ya. Bapak Ibu masih ada yang lain? Kalau enggak kita cukupkan sekian aja. Enggak ada ya? Dari chat kelihatannya sudah enggak ada. Is there any comment from speakers? Additional comment or additional? Enough? Apa? Oke.
Kayaknya sendiri gimana, Pak?
Oh, ya Pak Sugiartan.
Baik, Bapak Ibu, kelihatannya sudah nggak ada lagi. Is there any comment or okay, if there is no comment from the speaker, first of all, thank you for the all speakers, Dr. Kim, Mr. Kang, Dr. Jung, for the nice presentation and also the sharing from Mr. Arjam from the Tunnel Engineering Consultant, and also the comment and the question from the participant. Thank you again from the webinar. This today topic I think is very interesting, and maybe later we are also will discuss further, because we have to plan to conduct the study on the 2 Immerse tunnel in Indonesia, one in Sumatra and one in Kalimantan. And I hope in the later years we will have many tunnel project in Indonesia. Thank you, dan atas nama pribadi mohon maaf kalau ada hal yang kurang berkenan. Terima kasih, and applause buat seluruh pembicara. Thank you, Kamsiamida, selamat sore, assalamualaikum warahmatullahi wabarakatuh.
Thank you.
Saya kembalikan ke MC.
Thank you.
Oh, okay. Okay, thank you very much. Ladies and gentlemen, it has been a very warming discussion about the new technology about the Imos Tunnel. And thank you once again for our distinguished speakers here from Korea. Thank you very much. And we are coming to end our session today, and we would like to invite the General Chairman of Hpji, to Mr. Sugiartanto. The floor is yours. Baik, mohon maaf atas miskomunikasi yang terjadi. Kami mengundang Bapak Hari Purwantara untuk menutup international webinar kita pada hari ini. Kami mohon kesediaan Bapak Hari Purwantara. Oke, baik, terima kasih. Ya, mohon perkenannya Pak Atianto Busono untuk menutup international webinar kita pada sore ini. Silakan, Pak.
Baik, Bapak Ibu sekalian, terima kasih atas keikutsertaan dalam webinar kali ini. Dari siang sampai sore masih 400 sekian peserta ya, alhamdulillah. Dan saya kira apa yang kita dapatkan dari narasumber tentu sangat bermanfaat bagi kita semuanya, dan juga terutama kepada dalam rangka pelaksanaan ibu kota negara nanti, ya khususnya Immerse Tunnel, dan juga tentang soil yang betul-betul merupakan hal yang sangat berat ya, kondisi soil di sana, dan tentu akan mendapatkan banyak masukan, dan juga tadi diskusinya juga sudah demikian baik ya, kita dapatkan semua. Dan kami atas nama panitia, mohon maaf kalau ada hal-hal yang kurang berkenan, dan juga kepada para narasumber, especially to distinguish Mr. Kim and team, ya, thank you very much for all your presentations today. Dan juga saya mohon izin Pak Sugiartanto dan Pak Danis, kami menutup acara ini dengan mengucapkan alhamdulillah, dan sampai jumpa di webinar-webinar yang akan datang. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.